Good afternoon, students. This is Notes 2-7, which is linear inequalities. Our objective is the learner will graph linear inequalities and decide if points are solutions, and the learner will graph systems of linear inequalities and decide if points are solutions to the system. So first we need to talk about what a linear inequality is. A linear inequality is written in slope-intercept form. And all that means, if you remember, slope-intercept form is y equals mx plus b. But the equal sign is replaced with either a less than sign, a greater than sign, a less than or equal to sign, or a greater than or equal to sign. So let's go over some steps. You can read these on your paper. When you graph a set of solutions to a linear inequality, first thing you're going to do is you're always going to put it in slope-intercept form. And remember to flip the inequality if you multiply or divide by a negative. That's very important. And then next what you're going to do is you're going to decide on a boundary, on the type of boundary. If the inequality is a less than or equal to or a greater than or equal to, you are going to use a solid line, because some of the solutions can be considered on that line. If the inequality is less than or greater than, you are going to use a dotted line when you draw your line, because the points on the line are not solutions. The next thing you're going to do is replace the inequality symbol with an equal sign and use the slope and the y-intercept to graph the boundary line. Next, you're going to select a test point, such as 0, 0. You can use any point that you want for your test point, okay? But usually the 0, 0 is an easy one to pick, and you will plug that into the inequality. If it makes the inequality true, then you're going to shade the region containing that test point, which here was 0, 0. If it is not true, you're going to shade the other region. And then if you have a system of inequalities, remember all that means is two or more inequalities, then you're going to graph the other inequalities also. But just remember, the solution region will be where all of the shadings overlap. All the shadings overlap. So let's look at our first example. Our first example is 2x plus 3y is less than negative 3. So the first thing that I notice is that I have a less than sign. And a less than sign means that I'm going to have a dotted line as my boundary. Okay? So let's go ahead and get this into standard form, slope-intercept form. So to do that, you need to take that 2x and you need to move it to the other side, and so you're going to subtract it. So you will have 3y is less than the negative 2x, because you moved it to the other side, minus 3. Then if you divide both sides by 3, you want to divide everything by 3. I don't have to change the direction of my inequality because I'm dividing by a positive. But remember, if you were dividing by a negative number, you would flip the inequality. Keep this as negative 2 over 3x, that is your slope, and then minus 3 divided by 3 is minus 1. Okay, so for this inequality, my slope is negative 2 over 3, and my y-intercept is negative 1. So let's go ahead and graph that. Graph with your y-intercept first, so at negative 1, let's put a point here. And then I'm going to go down 2 and run 1, 2, 3. So this will be my next point here. And then I want to draw the line. Now remember, it's going to be a dotted line. So let's see how good I can draw this line. It's hard because I can't use a straight edge while I'm drawing it on the computer. So here is my my dotted line. And then let's pick a test point. So in this, for my test point, I'm going to choose 0, 0. Okay, so when you use your test point, you're going to plug it into the systems of inequalities. Well, this is, I'm going to put a 0 in for x and a 0 in for y. So I've got 2 times 0 plus 3 times 0, and I'm looking to see if that in fact is less than negative 3. 2 times 0 is 0, plus 0 is 0 less than negative 3. Okay, well, hopefully you're seeing that that is a false statement. So I'm not going to be shading where my point 0, 0 is. So right here, I am not shading this region. I am going to be shading below the line. So I'm going to shade everything over here. Everything below the line where my test point is not included. Okay, the other thing I want you to notice is that this is a less than sign. So the shading should be less than the border line. And you will, and hopefully you see that this shading is in fact below the border line. Moving on to the next example, now we have a system of inequalities because we have two inequalities. So the first thing, I'm going to graph this first one in red, and in the first equation, or I'm sorry, the first inequality, I see that I have a less than or equal to, which is going to get me a solid line when I graph it. So let's get that one into slope-intercept form. In order to do that, I need to move my x to the other side, which is going to make that a negative. So I'm going to have y is less than or equal to negative 2x plus 4. So let's go ahead and graph that. My y-intercept is at 4, so 1, 2, 3, 4. Here's my y-intercept. And then I'm going to use my slope, which is negative 2 over 1. So I'm going to go down 2 and over to the right 1 and put my next point. Okay, let's go ahead and draw our solid line. So let's do the best I can to try and make it straight. Okay. And of course you're going to have a straight edge because you've got your ID, and so you could make that a little bit straighter than I could. Notice that this is a less than or equal to, so this is going to be shaded below my line. Now remember, you can always put in a test point. We could put in the test point 0, 0 and see if this is correct. So this is my test point. I'm going to put in 0 is less than or equal to negative 2 times 0 plus 4 and see if this is true. 0 is less than or equal to 0 plus 4. So is 0 less than or equal to 4? Yes, it is. So my test point 0 should be part of the shading. So if you see right here, here's my 0, 0, and it should be part of my shading. It's less than or equal to, so I'm shading below. If you ever get confused about where less than would be, always just use a test point. Okay, so here's my first shading. Moving on to the second equation. Let me get some new colors here. Let me do a blue one. The second equation, this one's going to be a dotted line because it's a less than sign. Okay, so let's go ahead and let's get this y by itself. Okay, well, in order to do that, I'm going to have to divide everything by a negative 2. And when I divide by a negative, you have to flip that inequality. So I'm going to have y, but then I need to flip that and make it a greater than. Negative 2 divided by negative 2 is 1, so that's 1x. And then 3 divided by negative 2 is just minus 1.5. Notice I changed that to a decimal because that's my y-intercept and I need to know where it is on my graph. So at negative 1.5, that would be approximately right here. And then I'm going to rise 1 and go over 1, so that would be in the middle right here. And then I want to draw my line. Remember, it is a dotted line. Do the best job I can. And put arrows on the end of my line. And this is a greater than sign, so it should be getting shaded above my line. And remember, you can always put in a test point if you can't tell where above is. So it's going to be right here. Now, the solution would be the doubly shaded area. So I can make that just a little bit darker so that you can see that this, in fact, is my solution area. Okay. Sometimes what people will do is they'll put a big S in the solution area. So let's do that in pink. See if it stands out. Yeah, that's not showing up very good. But just know that this is your solution area. So if somebody asked you a question and they said, let's go back to black. If they asked you, is the point -2, 6, is that a solution? Well, you would go to -2 and you would go up 6, 1, 2, 3, 4, 5, 6, and you would want to know, okay, is that a solution right here? Well, it is falling in my doubly shaded part, and so yes, it would be a solution. Okay, anytime they ask you if a point is a solution, you want to look for it to be in the double shaded part. Okay guys, that's the notes for tonight. Short and sweet. Come ready to discuss in class, and have a good evening.